Hello everyone, I hope you're doing well, and today I am going to be sharing the research I've done regarding this question I found very interesting. Was maths invented or discovered? So before I actually share what I found, I will first explain what I mean by this question. And and what this means basically is, would maths inevitably exist, or has it exclusively been created by humans? So if mankind had never existed, would the evolution of maths have been the same? That's what I'm trying to investigate as such. This gets right into the essence of maths and why I think it's brilliant but mysterious at the same time. There are four main stances in relation to this debate, so now I'll dive into the different opinions which people take, one at a time, and I'll explore each argument's dissected meaning, strengths, and also some common counter-arguments made against it. So, the first one is Platonism. As the name suggests, it was made by the famous Greek philosopher Plato. And this is the belief that mathematical objects exist independently of humans and are discovered rather than invented. So these objects supposedly exist in an abstract realm which is neither physical nor mental. Now, the reason why this concept feels so compelling is because established facts like 2 plus 2 or 2 plus 3 is not an opinion. For example, I'll use the example I just said. 2 plus 3 equals 5. And regardless of what country you're in, what location you're in, what time it is, that will not change. So humans have done nothing to actually create that answer. It's a universal truth. And that's what Platonists think about theorems and arithmetic. Another example is prime numbers. Regardless of whether humans have discovered them or not, they have and they will exist. And Gödel, I might have pronounced that wrong, so I'm sorry if I did, but he was one of the greatest logicians of all time. And he argued that we have a kind of mathematical intuition similar to sense perception, so like sense of taste, hearing, etc., which is again something which we which suggests that maths was inevitably going to be discovered, whether humans had intervened or not. Now, with all that being said, there are still some counter-arguments made against Platonism. The main one is the idea that if these mathematical objects are abstract, then how do we even know anything about them? And also, at that point, how are they even real? How can we classify them as being real? This is known as the access problem, and it's probably the biggest challenge made against Platonism. Another perceived flaw of this belief system is that it commits you to an infinite realm of abstract entities, which some philosophers believe is too extravagant and convenient to even consider, and so they're quite pessimistic about it. So now that we've briefly analysed Platonism, I'll now talk a bit about another common stance which people take on this question, which is formalism. So you might be wondering why I've got a controller on screen, and it's because formalism is the belief that mathematical objects don't exist and are just a system of rules which are manipulated according to very explicit rules. So, unlike the abstract entities found in Platonism, formalism relies more on seeing maths like a game, which is why I've put the controller on the screen. And this game has strict rules, and this maths is being shaped by us with each discovery and each advancement. So the biggest strength of this argument is probably the fact that it avoids metaphysical commitment. In this perspective, 2 plus 2 equals 4, not because it's merely true, but because we define symbols and operations that way. But formalism too has its own weaknesses, the most significant one being its applicability. If maths is an adapting game, why does it resemble the universe so precisely? Gödel's incompleteness theorems showed that no formal system can capture all of maths' truths. So this suggests that the field of mathematics cannot be reduced to rule following alone. So that was the argument of formalism. Now I'll move on to the third argument, which is intuitionism or constructivism. So this view holds that maths exists only when constructed by the human mind. So mathematical objects don't exist independently but come into being only through mental activity. Anything that cannot be constructed is treated with suspicion by intuitionists. Intuitionism's firm grounding in human cognition avoids mysterious abstract objects, which are considered its major strength. However, the cost of intuitionism is that it disallows many standard proofs, especially those involving infinity or proof by contradiction, and so it's rarely adopted into mainstream mathematics. And so, despite sounding interesting at first, many mathematicians and philosophers believe it does more harm than good to the progress of mathematics. So, now the final perspective we're going to take a look at today is structuralism. So here it is. So I'll start by talking about the image I've put on screen. So I've put the dominoes now, and similar to how for a domino to exist, the relationship between the adjacent dominoes is important. So for when you push one domino, the adjacent one will fall, and then it's like a sequence. I know I haven't explained that very well, but basically structuralism is very similar to that. It argues that maths is not about individual objects, just like dominoes isn't just about one piece. Structuralism believes that maths is about relationships between these numbers. So if you take the number 2 for instance, it's not a standalone object. In fact, it's actually a position in a much larger numerical structure, because 2 is the successor of 1 and the predecessor of 3. Just like how a domino is behind another domino and in front of another, and together they form a sequence. So this belief is quite convincing because it actually preserves much of what Plato explains, but without committing to abstract objects. Structuralism explains why different structures can model the same mathematics whilst the connections and patterns remain a universal truth. Many philosophers believe that this is the most balanced view of the four. Now, nonetheless, some people argue that this stance shifts the question rather than answering it, because critics ask what exactly are these structures and do they exist independently or are human-made? And this question brings us back to where we started in the first place. So structuralism, some people believe, actually collapses back into Platonism, since it might be relying on abstractness again. So with that, we are done with this video. So I just wanted to conclude that overall, I think maths is a beautiful language with intricacies which I strongly appreciate and believe is essential for the advancement of the modern world. But when we look on the technical aspect of maths too much, I think we might be missing the philosophy and deeper mystery hiding behind this broad subject. So, yeah, please let me know in the comments which stance you align with the most. Thanks for watching and see you next time.